This time, I want to still talk about addition and multiplication between matrices, but I'm going to do this with two very special matrices. Well, they're not so special, but they do have important characteristics. The null matrix and the identity matrix. So let's see what happens when you multiply a matrix A with a matrix B, which is null. So let's suppose we have A, which is random matrix like 1, 2, 3, 4. Okay, something like this, like A. And we want to multiply it with, we want to do A times B, but B is going to be the null matrix, so 0, 0, 0, 0, just a bunch of zeros. So the product between A and B, it's going to be, A 1, 2, 3, 4 times 0, 0, 0, 0. So this is going to give us 1 times 0 plus 2 times 0. And here we're going to have, again, 1 times 0 plus 2 times 0. So it's going to be 1 times 0 plus 2 times 0. Then we're going to have 3 times 0 plus 4 times 0. 3 times 0 plus 4 times 0. And here we're going to have 3 times 0 plus 4 times 0. And not to my surprise, this is going to give us 0, 0, 0, 0, so a bunch of zeros. So we now know that if you multiply a matrix, any matrix, with to the null matrix, which is the matrix B here in this case, you basically get the null matrix again, so a bunch of zeros. So what happens if we instead we use the identity matrix? So let's just do, I don't know, still A is going to be our matrix 1, 2, 3, 4, and B is going to be, oh, sorry, I'm going to use I for the identity matrix, because, I, identity. So the identity matrix is basically a very important matrix with many particular and important characteristics, one of which is that it gives us, again, the same matrix in output as we add in input. So the identity matrix is basically a matrix which has 1 in the diagonal and 0 everywhere else. So 1, 1, 0, 0. This is a 2 by 2 matrix. So if we had a 3 by 3 matrix, it would have been 1, 1, 1, 4 by 4, 1, 1, 1, 1, and a bunch of zeros everywhere else, and so on. So is the identity matrix. This is important because we use it to find the eigen values when we are looking for the characteristic polynomial of a matrix. I explained this in another video, but anyway, this is one of the reasons why it's important. So let's try to do the product. So A times I. What's going to happen? Well, you're going to see it by yourself. No, I'm sorry. I'm joking. You're going to see it. I'm going to do it. It's pretty easy. Okay, so it's going to be 1 times 1 plus 2 times 0. And then we're going to have 1 times 0 plus 2 times 1. And we're going to have 3 times 1 plus 4 times 0 and 3 times 0 plus 4 times 1. So this is going to give us our matrix 1 plus 0, 0 plus 2, 3 plus 0, and 0 plus 4. And hey, this is 1, 2, 3, 4. This is exactly the same matrix we started with. So multiplying by the identity matrix gives us the exact same matrix we had before. So let's see what if we do the addition? So A plus the identity matrix. So A is going to be 1, 2, 3, 4, and I is the identity matrix. So 1, 0, 0, 1. Well, A plus I is going to be 1, 2, 3, 4 plus 1, 0, 0, 1. This is going to give us 1 plus 1, 2 plus 0, 3 plus 0, and 4 plus 1 is an addition. You just have to add each and every member. So it's going to be 2, 2, 3, 5. So we just added it, and we basically had all the elements in the main diagonal that are increased by 1, but the other elements have been left untouched. So adding the identity matrix to a matrix means that the elements in the diagonal are going to be increased by 1, but the ones that are not in the main diagonal are going to be left untouched. So this is why I wanted to cover it, the addition and the multiplication using those two special matrices, because those are some of the things that are kind of useful, because you don't have to do it yourself. I mean, you already know. You just memorize it. Well, you can do it by yourself and do all the calculation, but if you already know this and you see something like that, especially if it's something big or so on, like this one, if you have two very big matrices and so on, you just you don't have to do all the calculations, but you can do it. You can do it by knowing that this one is going to give multiplying the A times the identity matrix is going to give us the original matrix, multiplying matrix by the null matrix is going to give us the null matrix, and adding a matrix to the identity matrix is going to give us the same matrix, but with the elements in the main diagonal basically plus 1, so increase by 1. So this is pretty much it.